All right, 11:31, so we can probably go ahead and get started. And I do want to open this session, right, with this brief illustration of the concept of tragedy of the commons. And this basically describes, how shared resources, like whether it's water or land, or in our case, computing resources, can be overused and depleted when those resources are not managed properly. So let's just imagine a village, right, where the only source of animal food is shared land, and each animal owner has the right to use as much of that land as they need to. But there's not really a way to manage the usage of that land, right? So initially what you see is that the land is able to supply food for everyone's needs. But then, as the village starts to grow, what you see is that people begin to use more and more of the land. And ultimately, without a way to manage and regulate the usage of that shared resource, then some people begin to take more than their fair share of their food. And then ultimately that leads to shortages for everyone else. And so eventually the land becomes so depleted that there's not enough food for anyone. And the interesting thing is that this kind of tragedy can actually be avoided when you have the ways and the systems in place to make sure that shared resources are used in a sustainable manner. So rent contracts, which is the topic for today, right? That is the mechanism that we're introducing to manage entities and state storage on Hedera. I'm Ed Marcus. I work in the developer relations team for Hedera at Swirls Labs, and I also have Mohsen Kamar and Greg Sculler presenting with me today. So Mohsen and Greg, I'll let you guys introduce yourselves, maybe mention the product areas that you cover and where you're based out of. I'm actually based out of Washington metro area. Mohsen, go ahead.
Absolutely, yeah. So Mohsen, I'm part of the product team here at Swirls, and I am currently based out of Boston, Massachusetts.
And Greg, also part of the Swirls Lab team based in France and Europe. And as a developer advocate, I'm supposed to be subject matter expert on all things Hedera. So let's see how that goes.
You really are, Greg. You really are. So there's that. Excellent, guys. So, the goal for today is to give you all the key information that you really need to know about smart contract rent. And we're going to start with a brief overview of contracts on Hedera. Also going to mention some of the key recent developments on that area. And then Mohsen and Greg will give us the key information on rent. And then from there, we'll open it up to any Q&A or feedback you may have. So you can ask questions anytime in the Q&A box, and then we'll get to those towards the end of the session. So let's start with a quick overview on contracts. Now, I do realize that many of you already know probably a lot about Hedera and maybe a lot about smart contracts, but we probably also have people in the call and teams that may see this later that have been focusing on using our native Hedera services, right, for consensus or for tokenization. And they may be trying to learn more about smart contracts. So I'd like to bring everyone on the same page. And what you see here is basically the foundation or the engine of the Hedera network, which is the Hashgraph consensus algorithm. And so that is the engine for those services that I mentioned, right, for consensus, tokenization, and contracts. And with this part of the stack, we also have the Hedera Governing Council, bringing decentralized, transparent, and stable governance to the network. Then on top of that, that is where we have the applications and the use cases that end up delivering value to end users, right? Whether it's in the area of data integrity, payments, supply chain, identity, and a lot more. Now, if you're coming from the Web 2 world, or maybe you're new to this topic that we're covering today, smart contracts are actually just programs that are used to automate the execution of tasks when specific conditions are met. You can almost think of them as a digital vending machine, right? We all have used one of these. And so we know that a vending machine delivers a product, that is the task, when you, the customer, insert money, and also when you make a selection. So those are the conditions that have to be met. Now, a really good thing about smart contracts is that the terms of that agreement are actually written in the code, so anyone can actually inspect that agreement and that code. Also, I mentioned that contract can be programmed with conditions, but these conditions can actually be the receipt of a digital asset or maybe an amount of time that has to elapse before the task is executed. And also, just like a vending machine can sell you and automate the sale of a bunch of different products, smart contracts can actually automate the execution of different types of agreements and many different processes. So that's why we see them used in finance, supply chain, real estate, and a lot more. I also mentioned, right, that anyone can inspect the code for a contract, and that is because they're stored on the ledger, right, which makes them more transparent, tamper-proof, and more accessible. And since they can automate value exchanges, they tend to eliminate the need for intermediaries, which often leads to more efficient and more secure transactions. So with that background in mind, right, here's a simple example of a contract written in Solidity that actually writes data to the ledger and also reads data from the ledger. So simple words, this is just a setter-getter type of example. And so the first thing that you see is that here's the contract definition. So Solidity is actually a contract-oriented language. Then contracts usually also have state variables, and that is just data that is written on the shared ledger or on-chain. You're also going to hear that term a lot. And then we see the functions that users would execute when they interact with the contract. So here you see a function for setting or writing data to the ledger as the setter function. And here you see a function for reading data from the ledger or the getter function. And you also see a constructor, which is a type of function that executes when the contract is first deployed, and it's usually used to initialize state variables. Now, when you're working with contracts, it's typically a three-step process. So the first thing that you need to do is compile that Solidity code. And that is because the EVM, right, the Ethereum virtual machine, does not understand Solidity, doesn't speak Solidity. So what we actually need from that is the low-level set of instructions that the EVM can actually execute. And so that is the bytecode, and that is the output of that compilation process. So once we have that, what we need to do is create or deploy the contract to the network. If you're using the Hedera SDKs, right, the contract create flow command actually helps you do that very easily. And once you complete the step 2, you have basically installed your vending machine, right? You have now deployed the contract on the network. And finally, the third step is to interact with the contract, whether it is to read or write data to or from the ledger. And the SDK also provides, the classes and other objects that you may need to do that. So, there's plenty of documentation on how you can do this on Hedera, but here's also a quick reference guide or a quick cheat sheet showing you all the transactions and queries that you have available to interact with contracts using the SDKs. And one thing that I do want to note here, right, is that our smart contracts are actually interoperable with our other services. So you can actually have contracts that interact with the Hedera token service to manage and add programmability to those native assets that you may be working with native services. So now that we have that background about what contracts are, how they work, let's shift gear towards more recent developments. So over the past year or so, we have been focusing on making contracts more scalable and also more interoperable. And you may remember from last year that we made some significant improvements to the Besu EVM, and that is what we refer to as Smart Contracts 2.0, right? That is just where we made a lot of optimizations to that EVM so that it would work really well with the Hashgraph consensus algorithm. So now we can provide really incredible performance and cost benefits to contract developers. And also based on those scalability enhancements and upgraded gas limits, our contract service can process around 300 contract transactions per second, which is pretty good when you're trying to build dApps and other applications that provide an outstanding experience. We also developed a JSON RPC relay or interface, and that is actually really important for interoperability with other RPC native DLTs or distributed ledgers. Ethereum is one example of that, right? And And it's important because it enables exchanging transactions and queries between these ledgers. So what that means is that developers can now migrate to Hedera from other chains, and they can continue using those EVM libraries and tools that they're already familiar with. Or they can also deploy their cross-chain applications in growing networks like Hedera, and that way they can access new ecosystems and actually reach more users as well. And also one thing that I think is great about this interface is that it actually abstracts away a lot of implementation complexities, right? So, developers can just continue building, and then the relay takes care of handling the transactions to the mainnet and the queries to the mirror node and things like that. It just works. And then for this year, we obviously have some additional work to do just to close some gaps and also provide a smooth experience with this interface for contract developers. All right, so that is the amount of background that I wanted to provide about contracts, what they are, and some of the recent developments. And now it's time to focus our attention on rent and the specifics in that area. So just as a high-level reminder, those rent payments are going to start in February of 2023. So now I'll let Mohsen and Greg, give you some of those additional specifics. Mohsen?
Absolutely, sir. All right, so I'm not going to share anything that has not already been documented in the HIPs and been discussed with the community, but to provide some motivations, right? So first one was the improvement of the security aspect of the network. So as you all know, like the transaction costs of the data are low and the throughput is high. So that naturally gives us, you can say, sort of a disadvantage in terms of like if there's a malicious user and they wanted to choke the network because they wanted to send high number of transactions and disrupt the experience for other community members. The cost is just like it was just on that instance, right? So one of the motivations that we had was how can we increase the scale, increase the throughput without exposing ourselves to that additional risk, right? So rent considerations was part of that mitigation strategy that, hey, you pay for the transaction in time, but to persist that state, if you're a malicious user, the cost of persisting that state and persisting that malicious action goes high. Right? So that was one thing. The second one was how to, right now, the state can be persisted on the network for free, but it cannot be kept there forever for free, right? So the network has to be self-sustaining itself. Right. So that was another aspect of it is like, hey, how can we ensure that perpetuity of the Hedera network, whether the source lab is there or not, in a true decentralized fashion. So if the resources are used, how can we compensate for the cost of those resources? Right. And the final one being that what I mentioned earlier, once we have taken care of the cost of storing onto the state, and we have some check in place for increased throughput that a malicious user might exploit, then we can talk about scaling the network, relaxing some of the throttles. So those who might be familiar with it, we had a couple of instances recently on the testnet as well, right, where like certain actions were done by a small number of users and that kind of disrupted the experience for everybody else. And because of that, we had to reduce some of the throttles as well. So we want to go back, rather extend them further. There are exciting work that we have been doing, but we had to lay the groundwork in place first, right? So rent is part of that initiative. Now, why this particular implementation of rent? We considered an implementation where we could just increase the total gas fee. So like, hey, every transaction pays for that storage cost. So the cost of the storage gets amortized. And then there was some feedback from the community as well and internally as well that, hey, it actually disproportionately harms the new projects. The projects that just might trying to get adoption, they might not have the scale. So they are just paying higher gas costs and basically subsidizing is for other people who are actually using more state. So that was one aspect that we thought was not fair. The other implementation that we considered was similar to locking up some amount of balances. So in terms of like, if you lock a certain amount of HBARs in the entity, that increases that addresses the security side of things. Like, hey, if somebody is creating thousands of smart contracts, and every time they are, even let's say, for example, they are required to lock in 100 HBARs, the cost for their attack or cost for their action goes disproportionately high. The challenge there were some legal gray areas. We were not really sure, like, how the regulatory framework will look into that, and which regulatory framework to apply to it. So that was a legal no-no. So that's why we went with more of a usage-based pricing, which we thought that was more transparent, more predictable, and that provides a clear path forward. So again, as earlier as Ed was sharing, that has now been broken up into two parts. One is the entity. Like, whenever you create an entity, there's a fee that has to be paid to maintain that entity. Another one that will be coming up will be the storage-based side of things, right? And those details were shared as like, hey, there's under a certain key value pair level, the storage costs are exempt, and beyond a certain network scale, those costs kick in, right? So that's there. There is a workflow that is there documented in the HIP as well, that there is a grace period. So once an entity does not have the HBARs to pay for it, it gets a grace period of around 30 days, right? And then it is marked for deletion. And any other entity can pay for that rent and renew that smart contract. I know some of the community members have implemented a mechanism where one smart contract or one entity responsible is a main renter that pays for everybody else. So yeah, you can do that delegation as well. The treasury accounts for now, they are exempt. So if you have a smart contract that is allocated as a treasury, even if they don't pay the rent, they will not be considered for this expiry and deletion workflow. That is primarily there to provide community some time window, some adoption time frame, so that they can, if they have to refactor, if they have to adopt their workflows, tokenomics, they can actually do that. Right. So going forward, there will be additional, the rents will be coming in. The storage things that we have been considering will be for other entities as well. Smart contracts as are there, but like files, accounts, and stuff as well. Right. But before we get to that, there are certain aspects that we need to consider, especially what happens in case of expiry, what happens with the assets, how best we treat them, how can we treat them. We need to get some legal guidance as well. Some considerations there, and we will keep community in the loop as those discussions evolve. That is it. So yeah, Greg.
Oh, I was all organized. I thought you had another slide. So yeah, sorry, my apologies for the pause here. So let's dive a little bit deeper into what Mohsin has mentioned so far. So anyone who's created a contract on Hedera will know this most likely, although the SDK sometimes does hide some of those features. But when you create an account, a contract, you can specify what we call an auto-renew account and an auto-renew duration. The duration was initially limited to 30 days or thereabouts. It's been increased to 90 days, but the default remains 30. And the auto-renew account is entirely optional. If you do not specify one, then the contract's own account ID will be used for renewals or for paying the rent for renewals. So when we create this contract, the time at which we create the contract plus the auto-renew duration between 30 and 92 days results in what we call an expiry time, which is the time at which the contract will expire. And the cost of creating your contract will be determined by that initial auto-renew duration. So when you're creating the contract, you're paying for that initial 30 or 50 or 92 days as you see fit. My apologies. So at the time that the contract expires, and when the consensus time on the network reaches the expiry time of a contract, Hedera will try to extend the expiry time of the contract by its auto-renew duration. So what that means is that if you have an auto-renew duration of 30 days, a month after you've created your contract, it will attempt, or Hedera will attempt, to renew that contract for another 30 days. If the duration is 90 days, it will renew for 90 days. And the cost of renewal, in this case, will entirely depend on how long that duration is. If there is sufficient funds in the funding account, and we'll go into where that what that funding account looks like on the subsequent slide. But if there are sufficient funds, then the renewal is successful, everything goes very smoothly, and it's as if nothing had happened. On the other hand, if there aren't sufficient funds to pay for the renewal, then an initial renewal will take place for a partial duration. So what we mean by that partial duration is, let's, for argument's sake, these are not the costs, but I'm using simple numbers. If it's $10 a month to renew your contract, and you only have $5, then Hedera will renew your contract for 2 weeks, which is what $5 buys you. In reality, it will buy you a lot more than that. Of course, these are just simple numbers. If, on the other hand, the contract has there are no funds to pay for the renewal, then the contract will enter the grace periods that Mohsin mentioned earlier. Ed, next slide. Thank you. So who pays for those renewals? So as I said, when you create a contract, you can specify an auto-renew account, which will become the default payment account for that contract's rent. If there is no auto-renew account, or if the auto-renew account balance is 0 at the time of the attempt to renew, then Hedera will fall back to the contract's account ID. Yeah, either if there is no auto-renew account, or if it has a balance of 0, then the contract's account ID will pay for the rent. So, you know, technically now, who pays for these for this rent? Who funds those accounts? So of course, the expectation is that the creator of the contract is funding these renewals by keeping the accounts appropriately topped up. But there could be a concern, and I've seen it voiced in the community, that somebody might have created a contract and walked away. You know, they got fed up with it. They're not interested anymore. So how is that contract going to live on? So the answer here is anyone can transfer to either the auto-renew account or the contract account ID. So transfer HBAR, and at the time the contract renews, the rent will come from this account. And anyone can also extend the expiry time of a particular contract. So there's a transaction type called contract update, which enables you to extend the time or the expiry time of a contract, and the cost of that transaction is the cost of the extension. So one thing to bear in mind is that one of the reasons we have the auto-renew account on a contract is to enable somebody who has lots of contracts in the field to specify a single rent account for all of those contracts. It makes it easier to manage the rent. You don't have to top up lots of different accounts. As long as the one account is sufficiently topped up, then everything's good. But if you wanted to renew a particular contract that you're interested in, you need to be aware that if you pay HBAR into the auto-renew account, and that account is serving 100 other contracts, by the time the contract you're interested in attempts to renew, the funds in the auto-renew account may have paid other contracts renewals. So it may be preferable to extend the expiry time of the contract you're interested in, just to be sure that you're not paying for some other contract to be renewed. Some other options that, in terms of getting the HBAR required to pay for rent, we've seen different contracts implement payable functions, whereby whenever you call the contract or whenever a user calls a contract, they're essentially paying a tiny amount towards upkeep for the contract. And this sort of automates the whole process of putting HBAR into the auto-renew account or into the contracts account, and makes it fair on everybody else. If you're using the contract, you pay for a little bit of rent. Maybe as another option for the contracts that have a greater quantity of funds available to them, contracts can stake to a node. So you could get node rewards or rewards from the network to essentially fund or partially funds the renewal of the rent on the contract. So now, if none of this happens, of course, then the contract goes into this grace period, right? There's no funds, so the contract is temporarily paused, meaning that calls and queries to the contract will fail with a specific error condition. And the only thing that you can do during this grace period with the contract is update its expiry time with a contract update transaction, or send HBAR to the auto-renew account or contract account ID to essentially renew the contract and make it available again. There may be a small time delay in the event that you're paying the auto-renew account or the contract account ID. There may be a small delay before the contract is made available again to execute. It should be tiny, but yeah, just bear that in mind if you're using that method. After the grace period, if the contract can't be extended, then the contract will be marked for removal. If at the very precise moment that the network attempts to or verifies what to do at the end of the grace period, there are funds in the contract, then it will be reinstigated, of course. But if there are no funds available, the contract is marked for removal. It's not immediately removed from the network. It will stay in that pending removal state for a period of time. And in the future, this may be useful to prove that the contract was actually in a deleted state for a period of time before it was actually deleted, to enable you to prove the contract will be deleted. When it's been marked for removal, there is no going back. It cannot be reinstated. The next logical step is for the contract and its data to be fully removed from the network, and the identifiers of the contract, the contract ID and account ID, can never be reused. And this is to ensure, of course, that nobody can start reusing somebody else's contract ID and use it for malicious purposes. And then finally, if the contract does have or is holding any native tokens, then those tokens will be returned to the tokens treasury account. So there will be no burning of tokens, there'll be no loss of tokens, they will not be left in limbo. They'll simply return back to treasury for treasury to do what it wants with them. So I think that's it for now. I hope this was useful. And yeah, Ed, over to you.
Excellent. Thank you, Greg. Thank you, Mohsen. Now, we do have a few questions in the Q&A and also other ones that we received prior to the session, so it may be worth going through those. This is a question for Mohsen. You mentioned other entities. At some point, we'll start paying rent, but has that timeline for other entities been defined yet, Mohsen?
No, not yet. We will look into this maybe this year, maybe sooner, but I imagine hey, it will not be a surprise drop. Hey, it's happening this release. There'll be sufficient heads up, but we have just been having internal conversations on it at the moment. That
sounds great. And so then the key takeaway, I guess, is you only have to worry about contracts for now, contract rent. There's also a question about the auto renewal window. So Greg mentioned the durations of that from 30 to 90 days. And so a question is, how much would rent increase if you were to extend that auto renewal window from 30 days to 90 days? I'm happy to take that one. And basically what we notice is that those costs tend to increase almost linearly. So if you're extending the duration or the auto renew period by a factor of 3, then you can expect the rent cost to go up in the same fashion linearly by a factor of 3, basically. There's also one for Greg here, probably. Where will the auto renewal transactions appear, or where can I see the history of those transactions?
So they will be available via mirror nodes. There may be a separate API for them. I'm not entirely sure at this stage. Seeing that they will be available for mirror nodes, then Hedera explorers like Hashscan will be able to visualize them as well. So everything will be transparent. It's a public ledger. All of that data will be available to see and check.
Excellent. One question from Jake Hall that we addressed via the chat, but I think it may be worth sharing with everyone else. Where does the renewal cost come out from first? The contract itself or the auto renew account?
So the auto renew account first, and if that has insufficient funds, or rather no funds, then the contract account is the fallback.
Perfect. Question from Craig. Is there any rent charge related to deploying tokens through HTS?
So I'll take it. I think that touches on the first question you asked. There are no charges, or there is no rent on tokens currently, although that is being planned as part of the overall rent on entities in the future. So watch this space, or coming soon, or yeah, it will most likely happen at some point in the future. Yes. I should I know a lot of people see rent or hear rent and think, oh my word, you know, this is going to be expensive. The intention here is not at all for the rent on individual items to be, you know, so expensive it becomes unmanageable. When you consider a large or a network such as Hedera becoming very, very large, and, you know, potentially holding billions of entities, you know, put together billions of times a tiny amount is meaningful to the network. But on a per entity basis, those rent amounts should remain extremely low.
And that is a great segue to the next question by Jay. So how is the rent value calculated? I guess we may not have to get into the math of how those are calculated, but I think reminding people of the actual values that they have to keep in mind may be useful. So I'm happy to start. The rent, the cost for the auto renewal portion is 2.6 cents per contract, and that is for 30 days. So again, if you want to renew your contract for 30 days, it's about 2.6 cents. And then, as you remember from the slides, we saw that rent is equal to that auto renewal portion plus the state storage portion. Now, the state storage, you don't have to worry about for now. That will be enabled once a threshold is crossed cumulative for the network, once like a cumulative number of value pairs are crossed. I believe it's 100 million, and we're not quite there yet. So we're committed to providing plenty of notice for the community once that payment is about to start. But I guess the number to remember for now is 2.6 cents for 30 days. And then, Mohsen, I don't know if you want to mention something about how the rent value is calculated. I don't know if there's any merit.
Yes, so I can say like it was combination of few things. Is what's the cost of somebody choking the network, for example, the cumulative cost, like that was one factor of it. Like how many millions somebody has to pay through stolen Bitcoins or whatever to disrupt the network. The other aspect was like, what is the equivalent consumption of resources, CPU, RAM, and state itself. Right, so that was one factor. And finally, we also looked at like how the ecosystem is viewing it in terms of amortized costs and long-term sustainability on the data side as well. So those were the things that the council looked at. Like they are the ones who determine and approve these charges. But at a high level, these were the inputs that went into this identifying what should be the appropriate rent costs.
Excellent.
And as Greg said, nobody's making money off of it. So that was never the intent. It was more of security and threat prevention. And then that gives us a safety valve. So tomorrow, if we want to increase the throughput, and increase the state allocation and stuff, it just gives us like a safety that, hey, if somebody wants to abuse that throughput, there is a cost associated with it.
Sounds good. There may be also a question for you, Mohsen, around what are the legal implications? Can renewal accounts be seized as part of a civil litigation decrees? Ditto for account removal, renewal, etc.
I don't know. I can just say for the staking kind of implementation, one of the options that I mentioned, I think there the concern was that if the tokens are considered to have a value and we are using it, so we are kind of there are different disclosures within the US that you need to do. There's different compliance requirements that need to be done, and it was way too complicated, and we are not in that business. But rather, we do not want to be in that business. So that's why. In terms of what can or cannot happen, honestly, I don't really know. What can, who can seize what? It's the US government can decide whatever they want to decide. So I don't have any qualification to comment on that.
That is good. So there is a question from Jay Cole. Can you give an overview of key value pair storage fees and what it means? For example, what use case would a smart contract need to store key value pairs? I'm sure there is loads. I'm happy to start with that one, and then guys, we can add more to that. And for answering that question, I'm going to also touch on some of the resources that we'll make available to everyone and publicly available as well. So there is plenty of documentation around the smart contract rent, right? Explaining everything that is involved for auto renewal and storage. So you can come get that from the documentation. And then there's also a comprehensive set of frequently asked questions covering a lot of the topics that we touched on today. For Jake's question, I do want to point you to two articles as well that provide all the same information of the documentation. But basically, the thing to remember about key value pairs is that, again, those storage payments will start once a total of 100 million key value pairs are stored cumulatively across the network. And then here's the value or the cost per key value pair per year. So it's about 2 cents per key value pair per year. And then when you say, in what use case would a smart contract need to store key value pairs?
Can I just add to that, this metric that's there, 100 million key value pairs, knowing that it has an implication. So we are working to expose that metric as well, so people know is how close we are to that threshold. That's one thing. And secondly, once that threshold is reached, our plan is actually to provide community adequate notification. Hey, we are approaching that threshold. These are the applications, and then also updating the calculator where you can put in your contract IDs or IDs, right, and find out, hey, what might be the storage cost that might be due. But let's say it's a while away, at least for now. So not something that I'll worry about, at least in Q1 or maybe Q2. So.
Right. And so then I guess the other part of the question was in terms of use cases where contracts may need to store key value pairs. I think one example would be if a contract, and Greg, feel free to add, correct, or expand on this, but if a contract were to need to keep track of balances of I don't know, like an ERC token for certain accounts, those ERC balances wouldn't be stored on the ledger, right? Those are stored in the state of the contract. And so that information is stored as key value pairs in a way. And so that could be one possible use case. There may be others. I don't know if you want to mention them, Greg, or.
Yeah, I think generally, so I would try and avoid maybe using tokens as an example, because we have native tokens and that can create some confusion. But typically, and maybe I'll create my own confusion here. In a smart contract, you're storing data, right? And if we build a smart contract, for example, that stores the current temperature in every city in the world, then you need to have in your contract maybe a unique reference for a city, and this might be an address or a piece of string, and a temperature measurement. That's a key value pair. So if there are 100 cities that you're tracking temperatures for, you will have 100 key value pairs in your contract. If you're tracking 200 cities, you'll have 200 key value pairs. It's really, as simple as that. If you think of it as an array, for those of you who are programmers, it's the number of items in your array is your number of key value pairs. It gets a bit more complex with Solidity because you can create structures of data. So a temperature measurement might be associated with the time at which it was taken, the precise GPS coordinates, what thermometer was used, and all of that kind of expands the data to a little bit more than a single key value pair. I won't go into how Solidity sorts this out or how the EVM does this, because frankly, I don't think I understand it myself. But broadly speaking, for the majority of contracts, you're looking at a piece of data and a value against it, and that's your key value pair.
Excellent. All right, folks. So those are all the questions that we have in the Q&A at the moment, unless we receive any new ones, which we just did. And so, well, it's actually more of an acknowledgement. I guess there is a question towards the end of that, which is, if I follow you correctly, if we keep it to under 100 key value pairs, then one large contract will be hit with fewer overall small network fees per payment. Combining by class becomes important. Are those good basic assumptions? I'm not sure if I'm able to comment on that right now. That one may be a conversation worth following up on after the session, for any specific use cases you may have in mind. But unless you guys want to, respond to that specifically right now, we can probably.
I think maybe give some thoughts and ideas. I haven't got a calculator in front of me to work it out, but the question is, would it make sense to break up the state of a smart contract in lots of small smart contracts holding each 100 key value pairs to stay below the threshold? So yes, I mean, you could look at it that way. I think you might have to consider a number of things. The first is you have an extra cost for creating those extra contracts every time, which may be greater than the storage of the key value pairs. And the other question I would have is, how do you know which contract to ask for which value for any given key value pair? And you could have them sorted alphabetically, but then if you have a lot of A's and not many B's, then your A will have more than 100 key value pairs. I think conceptually it works. In practice, it probably would be much harder to implement, far more fragile, and could end up being more expensive.
Those are great thoughts, Greg. Thanks for adding those thoughts around, I guess, the architectural implications for your application that these approaches could have. But well noted. All right, folks. If there are no additional questions, I think we can call it a day at this moment. And then if anything else comes up later on, feel free to reach out to us via the Discord server, or maybe this, on the comments of this video once it's posted to YouTube. And we're here to help you answer any additional doubts you may have going forward. Thank you, Greg, and thank you, Mohsen, for helping us cover this topic with the community.
Thank you, everyone.
Thank you all for joining.
Thank you all for joining. Have a good day.
Bye.
Bye-bye.